based on the pattern we've seen in the last couple of videos, we're predicting that a problem like this might have 8 total solutions, doubling the b value. However, we're going to see that this problem actually doesn't follow that pattern. We will not get 8 solutions. So let's start this the same way we've started before. I'm going to ignore that 4 and just solve the equation sine of theta equals 1. And checking my chart, I see that, well, 1 is a special ratio. It gets us a quadrantal angle of just pi over 12. Or pi over 2, sorry. And so that's actually going to be the reason why this breaks the rule. Because that angle is quadrantal, we don't have 2 starting out points like we've had before. There's only one angle that gets us a ratio of 1, and that's pi over 2. And so, well, let's go ahead and then continue like we've done. So pi over 2 is not an answer. Really, what we know is that 4 theta has to equal pi over 2. And so solving this for theta then, I can either divide both sides by 4, or what I like to do instead is just multiply by a fourth. It's a little easier for me to do in my head to do that. And so I get my first actual answer of pi over 8. So I'll go ahead and circle that. Okay, just like we've done in the previous videos. What's different though is I don't have a second starting out point. So from here, I'm going to use the period of this graph to find my other answers, although it's just that one set of them this time. So recall that to find the period of a sine or a cosine function, my formula is 2 pi, the normal period, divided by the b value, which is 4 in this case. And so my period works out to be pi over 2, which will tell me how often my answers repeat. And so what I'll do with that value is I'm going to keep adding that to the answer that I had to start with. And as long as my answer is something that's less than 2 pi, it counts. Because remember, we don't want anything that's bigger than 2 pi. So using a calculator, if I need to do that for fractions, 1 over 8 plus 1 over 2 gets me 5 pi over 8 for an answer. That is less than 2, so I'll circle that. And I'll keep going, add another pi over 2. So 5 pi over 8 plus another pi over 2 gets me 9 pi over 8. That value is also less than 2, so I can circle that. I know it's less than 2 because 9 divided by 8, if I make it a decimal, is less than 2. Or think about it in terms of a fraction. 16 over 8 would be equal to 2, of course, if you simplify it. So as long as my numerator is something less than 16, I'm good to go. So far so good. Let's keep going. If I add another pi over 2 to 9 pi over 8, I end up with 13 pi over 8. That one's fine. And you may see a pattern as well. You're adding 4 in the numerator each time as you go down this column or down this row. So if I add 4 again, I'd end up with 17 pi over 8, which is an answer, but it's not an answer we can count. That's value's bigger than 2. 17 divided by 8's bigger than 2, so can't count that one. I get 4 total solutions. So not the 8 that we would have predicted, but that's because we were dealing with a quadrantal angle.